we're going to look at operations, with scientific notation, how we perform those operations. And one thing we need to remember is we really rely on the rules and definitions we have for exponents in these situations. So we'll start in with some examples here just to explain how this works. And let's say we have a number, maybe 7 times 10 to the third, and we're going to multiply this by 6 times 10 to the fifth. Well, when we're multiplying, the one thing that we need to be aware of, or the way we should work through this problem, is our integers here, or our numbers that we're multiplying by our base and exponent. We just need to multiply these together. 7 times 6 is 42. And then we can take rules of exponents. We know 10 to the third times 10 to the fifth is the same as 10 to the eighth. So we're really looking at 42 times 10 to the eighth. However, remember in scientific notation, we can only have one number to the left of a decimal point, and here we have 2. So really we've got to change this. So we've got to say 4.2 times 10. Now we made this side smaller. So to equal it out, we have to add 1 to the exponent on the other side. So 4.2 times 10 to the ninth is what we're talking about there. And to illustrate how this works, let's do this long ways. 7 times 10 to the third we know is 7,000. 6 times 10 to the fifth would be what? 6 with 1, 2, 3, 4, 5 zeros, 600,000. So if we look at 7,000 times 600,000, what we get is 1, 2, 3, 4, 5, 6, 7, 8. So we're here. If we want to put this in scientific notation, of course, we have to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 places. 4.2 times 10 to the ninth. What about when we have a quotient? What about when we're dividing? Well, when we're dividing, it's kind of the same thing. Let's say we have 8 times 10 to the fourth divided by 4 times 10 to the negative. And then we'll make this positive. 4 times 10 to the third. Well, again, we can just divide here. 8 divided by 4 is 2. And we bring this up, we get 10 to the third. We're looking at 10 to the fourth minus 3. So it's 2 times 10 to the first. We could just say it's 20. But if we do this out long, then let's see what we have. We have 8 with 4 zeros. So it's 80,000 over 4 with 3 zeros. 4,000. 80,000 divided by 4,000. And get our zeros out. We're looking at 80 divided by 4 is 20. So we'll do another one that's a little different. Let's say 1.3 times 10 to the fifth over 2.6 times 10 to the negative third. So if we look in this case, what we're going to see is, oops, lost it there. What we're going to see in this case, get back to my whiteboard here. There we go. Get back to this case. What we're going to see here is 1.3 times 10 to the fifth. If we want to look at this, we're looking at 1.3. We'd be moving the decimal points 1, 3, 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5. And this would be over 2.6 times 10 to the negative third. We'd be moving the decimal point 3 places to the left, so we would have 2, 6, 1, 2, 3. So 0.0026 is what we have here. Now if we look at this and work this out, 130,000 divided by 0.0026, what we get is 50 million, which we know should be 5 times 10 to the 1, 2, 3, 4, 5, 6, 7. So how can we do this? How can we think about this without doing this long ways? Well, we know 1.3 divided by 2.6 is 0.5. That's easy enough to do. If we bring this 10 to the negative third up, this becomes 10 to the third, and we would have 10 to the fifth plus 3, which would be 10 to the 8th. Okay, so we have 0.5 times 10 to the 8th. However, remember, we have to have one number to the left of the decimal point. So we're going to move this decimal. So we're making it 5. That makes this side bigger. We have to conversely subtract 1 from this side. So we got 5 times 10 to the 7th. So we can shortcut it doing this, or we can do the long way, where we calculate everything out. For larger numbers, that's going to be a lot harder. But using this this method here and computing what we do with these numbers in scientific notation isn't too hard. Remember, it's based on our exponential or exponent rules we have for exponents. So, see you in the next one. Have a good day. Bye.